Hi, my name is Rachel O, and today I will be going over acids and bases and how to calculate the concentration of hydrogen ion and hydroxide, as well as the pH and percent ionization of a solution given its concentration. Specifically, I'll be looking at Part 2, Problems E and F from Workshop Number 7. Question E of Part 2 in Workshop Number 7 asks to calculate the concentration of hydrogen ion and hydroxide, as well as the pH of a 0.800 molar nitrous acid solution. The only value given in this problem is the concentration of the nitrous acid solution, which is 0.800 molar. We can begin this problem by first writing a balanced equation for the reaction of a nitrous acid solution. Nitrous acid is HNO2. With that, we can begin to write our equation, which will be HNO2 plus H2O, double arrow since HNO2 is a weak acid, H3O plus NO2 minus. Because nitrous acid is an acid, it will donate a hydrogen to create H3O plus and NO2 minus. I will approach this question using a rice table to derive the concentration of hydrogen ion. I then continue to fill out the rice table. The initial concentration of nitrous acid is 0.800 molar, which is given in the equation. Water can be ignored in the equilibrium reaction because it is a liquid. And initially, hydronium ion and NO2 minus will both have concentrations of 0. It is important to note that hydronium ion and hydrogen ion are the same thing. Continuing on, the change in concentration for nitrous acid will be minus X since it will lose 1 mole of nitrous acid, and the change in concentration of hydronium and NO2 minus will be plus X since it will gain 1 mole of each. Then the equilibrium concentration for nitrous acid will be 0.800 minus X, and hydronium and NO2 minus will be X. Using this rice table, we can then calculate the concentration of H plus using the Ka, which is the equilibrium constant for acid, equals the concentration of hydronium times the concentration of NO2 minus, divided by the concentration of HNO2. We can find the value of Ka at the back of the workshop worksheet or table 16.5 in the textbook. This value of Ka for nitrous acid is 4.0 times 10 to the negative 4. We then set the rest of the equation up with the equilibrium concentrations we solve for in the rice table to get 4.0 times 10 to the negative 4 equals x times x divided by 0.800 minus x. To bypass having to do the quadratic equation to solve for x, we can use the x is small assumption. To calculate this, you would solve for x if x were small and then multiply this by 100. This calculation would be the square root of 4.0 times 10 to the negative 4 times 0.800, and then multiply this value by 100, which will equal 1.79%. Since this value is less than 5%, we can use the x as small assumption. We then go back to solving for x, and since we can assume x is small, we cross out x in the denominator and then solve for x. This would equal 1.78 times 10 to the negative 2. To find the value of the concentration of hydrogen ion, we look at the reaction equation and we can see that hydronium, which is the same as hydrogen ion, equals X. Thus, the concentration of hydrogen ion will just equal 1.78 times 10 to the negative 2 molar. To then calculate the concentration of hydroxide, we can use Kw equals the concentration of H3O plus times the concentration of OH minus equation, since we have the concentration of H3O plus. Kw, which is the equilibrium constant for water, equals 1 times 10 to the negative 14, and we set that equal to 1.78 times 10 to the negative 2 molar times the concentration of hydroxide. And then we just solve for hydroxide, which equals 5.59 times 10 to the negative 13 molar. Now to solve for pH, we can use the pH equals negative log times the concentration of H plus equation. We plug in 1.78 times 10 to the negative 2 for the concentration of H+, and we get 1.750 for pH. That is it for Part E, and now Part F asks to find the percent ionization of the solution above. To find percent ionization, you divide the concentration of hydrogen ion by the concentration of the original acid and multiply this by 100. We would get 1.78 times 10 to the negative 2 molar divided by 0.800 molar times 100. Once we plug this into the calculator, we get 2.23% for our percent ionization of the solution above. To summarize, Part E asks to calculate the concentration of hydrogen ion and hydroxide as well as the pH of a 0.800 molar nitrous acid solution. We found the concentration of hydrogen ion by filling out a rice table and using the x is small assumption to bypass the quadratic equation to solve for x, which equals a concentration of hydrogen ion. The concentration of hydrogen ion equals 1.78 times 10 to the negative 2 molar. We then solve for the hydroxide concentration by using the Kw equals concentration of hydronium times concentration of hydroxide equation. We get 5.59 times 10 to the negative 13 molar for the concentration of hydroxide. We then solve for pH by using the pH equals the negative log times the concentration of hydrogen equation, and we get that pH equals 1.750. For part F, the question asks to find the percent ionization of the solution in part E. To find percent ionization, we divide the concentration of hydrogen ion by the original concentration of the acid and multiply by 100. We get that the percent ionization of this solution is 2.23%. Thank you for watching my video.